So I thought today I would lead you through a very practical example of our engineering practice. And in Holland, everybody loves activity-based working now. And well, of course, that brings something to it regarding acoustics, acoustic comfort, and speech privacy. And a little bit of the content, a short introduction, and then how we approach the investigation to speak in clarity to our contractor, what to expect, and what the range is, how to improve the acoustics during the design process. So I as well really depend on investigations as leaseman to get the attention to the problem that acoustics often is not regarded as a very important input in the design process. And not only acoustics and noise levels, but as well temperature and air quality. And those are all things we cannot see, but we do experience them. And it really involves or influences, I think, as well in our capacity to sense our environment and still to do our work. And I think both are very important to us as human beings, that we are comfortable and we enjoy our environment and the people around us, and that we can do our job. Big questions for the contractors is, what quality do I want and what quality do I get? And how can I control that quality? So for example, the government in Holland, they can only say, I want to use that building and please make it right. And they don't have actually influence during the process. So they put a lot of effort in a set of regulations, but whether or not it's going to be real in practice, well, that's the question. Because the existing building, it's there, and the ventilation system is there. And what to do if your wishes and demands for acoustic comfort cannot be reached in practice? Who are you going to blame? Or how are you going to solve the problem? Or how are you going to communicate that the quality might be a little bit different than can be expected in new built buildings? So I'm sorry, as an acoustician, you need some parameters to shout. And it is not 1 dB only. So I had this contractor. This is a practical example of the result of this kind of retrofit building project. And by that time the project started, I got 2 phone calls. One was of the contractor who said, listen, I have a company who wants to sell acoustic panels. Can you please show that there is no relevance in putting acoustic panels? So that was one question. And the other phone was, hello, I'm the supplier of acoustic panels. Can you please tell the contractor the relevance of putting acoustic panels in this project? So I thought, what's wisdom and how to speak of quality? And the contractor said, oh, can you not measure and then show the increase or decrease of dBs? And I said, but what dBs? He said, yeah, just measure. Because it's a big engineering company and they love to measure. So if you measure, it's true. But I said, but you can measure a building, of course, and then if you measure it tomorrow, it's the same. But the people, they move and they talk and they exist. And it's not only the quality of the building, but the combination of the people that actually use the building that proves it whether or not to be a success. So one organization is really quiet and produces less noise, and the other organization really enjoys a lot of noise because they need the interaction between people. So what's good and what's bad? These are the building parameters we use to define a building. So I won't go really into the parameters, but I'll show you a little bit about the whole project we made. And we suggested we do make a start with baseline measurements, because then you know what the people are used to now, and you know what the building is doing right now. So you can make some comparison in before and after. And we use the acoustic norm of open plan offices, and we measured well, along the long lines. It was not a very inspirational office in the beginning, I have to say, and of course that's my opinion. So this line is just measured the line you see on the picture, and well, there's quite a good ceiling in the building, and the sound decay over distance is 6 dB. And we did some other measurements. I'm sorry, the main results are a bit low. I'm gonna wait. So they decided they wanted a meeting zone, and they put some sound barriers and absorption panels. But actually, not a lot of people were using that zone. So the interaction was still on the floor here. And well, you have some closed rooms, and we measured the sound insulation, and it turned out to be really bad, like 29. For the acousticians, they know how bad it is a little bit. It's about, if you stand in front of a room and the door doesn't really close well, you measure 29. So if you do a really private conversation here, and you were sitting in the meeting room next to it, well, big chance that you could almost hear the conversation. So we thought not only the building you want to measure, but as well as the behavior. And how do you do that? We took our sound measure equipment, and we, for 1 week, we made microphones hanging under the ceiling, so people thought the FBI was coming. But it really gave us an insight of how much interaction there actually was on the office floor. So how the floor was used, and what do the people need as acoustic comfort in a new situation. And then you get this kind of graphs. And you see that well, the yellow zone that was actually meant to be the most interactive zone was the least in use and quite quiet. So what really happened is people just talked at their desk. When they had a meeting, it was at their desk. So when you sat next to someone who was having a meeting, you will totally enjoy the meeting and maybe not so much do your own job. We put the measurement results in a histogram, and then you can see that the light blue and the blue zone almost had the same results. So there, you could say there was absolutely not activity-based working in the old situation. So from the baseline measurements, we got some input in what we thought was really important for this company, and then we started to engineer the new design. So they really wanted interactive behavior. I think that's really good. But please think well whether or not you want that in an open plan office. So we decided to make closed rooms for the meetings and for the conference call. And within the office, open plan office, we had zones of interactive and quiet. And you came out from this side. So first you have the interactive zone, and when you kept walking, you walked into the quieter zone. I think it's really important that you communicate it well, also in the visuals. You see here the green, that is the interactive zone. And the furthermore you got on the office floor, the screens were a bit higher and the color was different. We used this as also as an engineering possibility, and I modeled it in CAD acoustic, to show not only ourselves but as well as the people we worked with what the effect can be of a zone making zones and how the sound stops when you put a sound barrier. So the big thing you see here, it's modeled in here, and this is the one without the sound barrier, and you can see that the sound decay is quite, well, too good. You don't want it that way. And when you put only one barrier in the plan, it already very much helps to. You can think of zones that is different, but actually you need something in the building that separate the zones. Otherwise, it will become one big blurry zone in the end as well. And because of course, you want to see what happened afterwards, we ended the whole project with control measurements, and where we measured 6 dB of sound decay in the old situations, we measured up to 9 in a new situation, and we were quite happy with it. So For us, that's a way to measure whether or not the zone between interactive and more quiet, whether or not it's really produced in the building as well. We as well measured the behavior of the people. So on the left you see the old situation, and well, we have a Dutch guideline, and there are levels of sound described. Whether or not you can do office work has to do with whether or not the sound level, noise level is above 55 dBA or below. And in the new situation, we were very happy to see that the noise level went down. And I think that that shows that the behavior of the people changed, that whenever they had to discuss or interact, they decided, let's plan a group meeting inside the room. And I think that makes the people around really happy. This is the project I wanted to show. And I think out of practice, well, you can talk about acoustics, but whether or not it's going to taken seriously, it really depends on how you explain it and who you talk to. And often only afterwards we get called like, something went wrong, can you please come? But from this example, I hope we all get excited to communicate more, interdisciplinary, like what to expect if you have an existing building, an existing company, and you want to do everything new. Let's talk to one another. In this project, we had some issues with, for example, the ventilation system, because right where the concentration cells or the conference call cells were made, above the ceiling, a lot of candles would go over it. So we demanded really high values for acoustic insulation, but when we measured, some of them were really, really low. And it's such a pity when you think you're doing everything right and you set high demands, and then in practice, you do not get to reach that goal at all because there is not enough of interdisciplinary discussion and insight in each other's field, what is really important, whether or not you reach the quality. So I hope this conference helps us to work together more and to be aware that quality is not only reached in our own acoustic language, but maybe even more in talking with one another and creating the design together. So thank you for your attention.